In chapter 18, we're going to look at forecasting with time series. Before we actually go through forecasting and look at simple moving averages, let's just briefly, I want to talk about forecasting versus prediction. We just came out of chapters on regression, simple linear and multiple regression. So when we use regression analysis, if you recall, we had dependent variable and we had independent variable. So the difference between prediction and forecasting is this. Anytime you use two or more independent variables to predict the value of independent variable, you're confined within the scope of those independent variables. So for example, let's say I want to predict a person's net worth based on their income. So in my sample, if I have people with incomes between $50,000 to $250,000, then the scope of that prediction lies between $50,000 and $250,000. I cannot go beyond that. I cannot go, for example, predict the net worth of a person whose income is $300,000. So with prediction using regression, we are limited to the scope of independent variables. We cannot go beyond. With forecasting, we actually talk about time series. What we would like to do is we would like to actually predict in the future. That's something we haven't done yet, although we did regression. But it's noteworthy that to mention here that regression forecasting is indeed a forecasting technique. We just need to modify some assumptions which allow us to go beyond and extrapolate beyond the scope of data. Okay, so I just want to point that out. So in chapter 18, we're going to just talk about moving averages. So other techniques are beyond the scope of what we want to do. So what is a time series data? It's simple. Time series data is any data that is collected over time. That's why it's called time series. So it's data collected over time. So for example, I have here the closing price of XYZ stock over the last month. That would be example of time series. Or we can think about, let's say, sales. We can think about sales, retail sales at Walmart. You can look at, for example, the earnings of companies over the quarters, monthly earnings, quarterly earnings, annual earnings over time. So the objective again is to forecast future values of the dependent variable. Now, one thing that's really important here to note is that when we use time series analysis, time is always independent variable. That's always the independent variable. Remember, time is going to go on. Time's going to happen regardless of what we do or what happens in the world, right? So time does not depend on anything. Time is just something that happens. So you never forecast time, okay? The dependent variable, of course, is the variable that you would like to track and ultimately would like to forecast over time. So here I have some clips from your textbook. This is an example of time series. So here we're looking at the number of sales associate at Home Depot between the years 1993 and 2018. So look at that steady rise of number of employees or associates in thousands. So in the mid 1990, let's say 1993, looks like that's the beginning of this data, right? Home Depot had about 50,000 associates, and because of prosperity over time, the company has grown to over 400,000 employees. So you can kind of see that secular trend over time. Okay, so this is example of time series. Notice the independent variable in this case is years or time span. These are yearly data. The time span could be as little as 1 minute. It could be minute, 5 minutes, 15 minutes, an hour, a day, weekly, monthly, quarterly, semi-annual, annual, whatever. It could be whatever that it is, collected over time, whatever your time preference is. Okay, so this is example of time series. Now, there are 4 components to any time series. Okay, so we have what we call trend, seasonality, cyclicality, and of course you have irregularity or error or noise. So we're going to look at each of these briefly. First of all, trend. The trend is, as your book calls it, the change of variable over time. Now, the trend could be a secular trend, linear trend. It could be exponential trend. It could be any kind of trend. It doesn't have to be linear, as long as there's some kind of a trend in the data. With these trends, we're usually looking for upward, downward trends. Okay, now they can go up in an exponential manner, or they can fall in an exponential manner, as long as there's some kind of a trend. Okay, if the variable doesn't exhibit any up or downward trend, then we call that a stationary. And our focus with the course is indeed these kinds of series, the ones that are stationary, because we're going to use moving averages to analyze these. The other component of every time series data is seasonality. So the seasonalities, these are predictable, short in duration, 3 to 6 months. So here's an example of data that exhibits seasonality. So here we're looking at sales of baseball and softball equipment from 2017 to 2019 by quarter. So here our time is quarterly data. First quarter, second, third, fourth, fifth, sixth, and so on. Now notice in here what the authors have done is they have thrown in the trend. So you see that kind of gradual low slope trend, secular trend. And then you have these cycles. So it looks like the sales of baseball softball equipment is highly seasonal. Something else that's happening also, I can see by just moving the cursor over it, is that the variability in the data is increasing also. Not only the seasonality, but also the variability is increasing. So that's interesting to note. So again, here's the trend. And of course, these looks like, let's say this is quarterly data. So first quarter, first, second, third, fourth, 5, 6, 7, 8. So it looks like third, fourth quarter, the sales dip, right? The last 2 quarters of the year, the sales dip. They do it here also. They've done it here also. And then looks like the first 2 quarters actually, Q1, Q2. The first 2 quarters, the sales are higher. There you go. So that's the idea of seasonality in the data. So highly seasonal. But keep in mind, the seasonal patterns are short-term in duration. Okay? And then we talk about cyclicality. So these cycles are kind of like seasonal patterns, except with the cyclicality, the cycles occur over a longer period of time. So some cycles may be over a year, could be 2 years, 8-year cycle, 30-year cycle, depending on the phenomena. So remember, cyclicalities are longer period and they occur over many years. And usually, again, these are more challenging to see, because if something, for example, goes through a 50-year cycle, I may not be around for 50 years to analyze that data and eventually make note of that cyclicality in the data. So usually these are more challenging than seasonal data. Here's an example of cyclicality in this time series. So look at the time span from 1995 to 2020. So we're talking about 25 years. So you really have to be patient with this data. If you collect in this data over 25 years, then of course you have a good, genuine time series. But look at this one. This one has the secular trend, of course, So it's made up of trend, and then it has these very pronounced up and down cycles. So it looks like these are the period of prosperity, and then you have the periods of depression. The low points are depression, and then so you have this very nice cycle. So it looks like it's a 2-year cycle, right? So that's what we mean by cyclicalities. Okay, because they're over 1 year, typically over 1 year. So in this case, it looks like 2-year cycle that the economy goes through. Okay, and then of course we have this fourth and the final component, which is the noise. Okay, the irregular component. It's just, there's no explanation for that. So we call it random variation. Okay, so again, just to point out, in this course that we're doing, we look at the simplest type of time series, the ones that are trendless. Actually, there's no trend to them. So we're gonna look at the stationary time series. Okay, now what's the best way to forecast a stationary time series? It would be a simple moving average. Remember, stationary does not have a trend, so I don't have to worry about the secular trend. I don't have to worry about seasonality or cyclicalities. So you have trendless data that basically moves sideways. Okay, and there you go. We're going to use simple moving averages. Now, one thing that is again noteworthy is that the moving averages kind of smooth out over the data and filter the noise from random fluctuations. And I'll show you an example of these in just a moment. I have a few charts for you. Now, if you look at the difference between the actual value and forecasted value, the difference is what we call the forecast error or deviation. That's what that is. Okay, so the forecast error or deviation again is the difference between actual and forecast, and usually we look at the absolute value of that. Okay, now one measure of the error associated with the forecast in a simple moving average is MAD or MAD, which stands for mean absolute deviation, right in here. That's mean, and then A is for absolute and D is for deviation, and the acronym MAD here. You see that? So that's what MAD is. So how do we calculate this MAD? Well, it's very simple. You just look at the absolute deviation, add them up, all these deviations, and then divide it by number of errors that makes up that total. So remember, this is absolute value symbol. So plus, positive, negative doesn't matter. We just take it to be positive. Okay, and also here, when you use a moving average, you should actually decide on the number of past periods. How many periods you want in your average. Now the common ones for monthly data are 3 and 6 months. Okay, it really depends on the data. I have example of for example stocks that I've put on there for you. I've looked at one company. You all know about this company most likely, so I'm going to show you that one. And for the one we were about to see, I actually used what you call it, sorry, I'm trying to make everything kind of uniform here for you. Okay, so for daily time series, so if you're trying to forecast, let's say, a stock's price, you use 14-day, 50-day, 200 moving day, and so on. Now, one thing you should note here also that I have, the larger, then the greater the number of periods would be, the smoother the series is, and it takes longer for the series to turn with the actual future data points. Because again, remember, this is kind of a trailing, means behind. It's a trailing average. So future values occur. If you do a 200-day moving average, what happens tomorrow doesn't immediately reflect in the average, because there are 199 other days to average. So it's not good for short-term forecasting, the 200-day moving average. But maybe if I want to do a short-term prediction on anything, I'm just better off to do a 3 or 6 period, and that would quickly pick up the turns in the data, in the time series data. Okay, now if you use more than, let's say, one kind of simple moving average, let's say you use a 3 and then you use a 6 and then you use a 9-month moving average, choose the one that results in the smallest MAD among all the other moving averages. Okay, so here's an example. I actually did this in Yahoo Finance. Very interesting. In Yahoo Finance you can do this, capable of doing moving averages. So here is actually the price of this company. I'm sure you all heard of it, Tesla. So here, notice for a long time, for a few months, there's not much of a trend here. So this would be ideal for a moving average forecasting down here. That would be from, let's say, June through November of 2019. And then in November you have this secular trend, and of course the trend here, it looks like an exponential, right? One thing also you got to be careful is this: if you, let's say, if we are not going to, but if you were to fit a trend model through this, you got to be careful, because my model is going to pick up this curve and it's going to continue on in this direction. But look what happened after that. The stock dipped, right? So we got to be careful. We cannot really do too many periods in the future. Okay, so anything you do in the future, of course, is subject to error, and there are no guarantees that things will happen. Imagine if you didn't have this portion of the chart, right? And if you follow the trend here, I'm talking about this portion of the chart. If I didn't have that, if I only had that portion, then look like the trend is downward and continues on a downward path. But then suddenly there is a change. So anyways, there's clearly I don't see any cyclicalities. So this is the data that actually does have a trend, but it's littered with noise. And the noise is because this Tesla stock, of course, is a bit controversial for a lot of reasons. So that's why the overall trend, I would say, there you go. This looks like this. There is this parabolic trend, right in here, that parabolic trend. And then something happened here which deviated from being parabolic. Here it got ahead of itself, and so did it here. So there's a disruption here. That disruption lasted from February through almost May. And this is, of course, the time of where all the COVID-19 stuff was happening. And of course, the dip that most stock were inflicted right in here through March, I believe, 23rd. So, barring this unforeseen event, we want to fit a moving average through this. So what I've done here, I've actually picked up a 14-day moving average, and I did a 50-day, and I did a 200 moving day average for you to see the difference. So this one, the one that's in blue right here, up here, I'm tracking it right now. See this one? That's very close to the actual series itself. And right up here, that's the 14-day moving average. Notice how sensitive it is. More sensitive, more so than 50 and 200-day moving averages to recent fluctuations. You see that? It's picking them up. Probably for a stock like this, I would go as low as 7-day moving average if I want to make a forecast. Okay, so 14-day for Tesla is too long. Okay, and then we have this 50-day moving average for the ones that actually want to look at the longer trend. So you see that one? So it seems like there is an overall trend, upward trend ignoring all the zigzags. And that's what 50-day moving average does. Now look at the 200-day moving average. It has this nice slow growth, right in here. Okay, and it's purely coincidental that right in here the stock, or see that the low point here is like around what, $400 some, 450, that it touches the 200-day moving average and bounces up. Because remember, when data is in here, the 200-day moving average is actually further back. And there you go. So if I'm looking at, let's say, tomorrow's forecast, what is Tesla gonna do tomorrow? Well, I would rather to make a prediction using 14-day moving average. You see how it's high up here, 1489. That's much more realistic than I say, okay, well, tomorrow my forecast is going to be about 1200, give or take. That's definitely wrong. And I'm not going to definitely use a 200-day moving average to make a forecast. $724, that's half the price of what it is. It's not going to do $700 in a day. So again, these longer periods are more for smoothing the noise and just looking at really over long period of time, for maybe for long-term investors. Okay, so that's the idea of moving average. So how are we going to do this in Megastat, right? Okay, now let me also mention that Megastat is very limited in what it can do with time series, very limited. But then it's what we're using for this course, just to give you some exposure into the idea of time series. Okay, so here's an example, and you're doing an exercise where it's similar to this one. So in this example, you want to use simple moving averages and this time series data to answer these questions. So here's our period, 1 through 10. We don't know what these are. It could be quarterly, monthly, yearly, we don't know. Whatever they are. So we have period 1, 2, 3, 4 through 10. And then we have the demand numbers, 130, 122, 21, and so on. So our independent variable is period, and our dependent variable is demand, the units of demand, whatever these are. So let's do A, B, C, D, and E here. In part A, graph the time series data. What do you observe? So I did, and I did this in actually using Megastat. Well, actually the chart, let me correct myself. The chart itself is not done in Megastat. Megastat doesn't do that. Megastat, it will do time series, but it will not do this chart. I'll show you how I did this in Excel. Very simple to do. And there you go. Now notice in here there is no trend. See the sideways? Pretty much sideways here, flatlining. So if I was to actually put a line through it, I would do a horizontal line. And this is what I mean. My line is pretty much is going to go like that. So that's why we say there is no trend in this data, and therefore a simple moving average is best for forecasting. Okay, and there you go. This looks like this would be my forecast based on this data. And that's really what moving average does. It just gives you a forecast based on the previous 3 to 6 periods. That means based on these 3 periods, it gives me the next forecast if I'm doing a 3-period forecast. But then we can also see a couple of points here, which right here, you see that? So that would be the seasonality in this data. So it looks like there is some seasonality, but definitely no trend in this data. So that I just want to point that out. And the reason, because it does mention what do you observe. So that's what I observe. The data that does not exhibit a trend. So the series is a stationary, and there is possibly seasonality. It looks like definitely a seasonality in this data based on period 1 through 10. In part B, compute all possible forecasts using a 6-period simple moving average model and compute the math. Again, let me show you this and then we go in Megastat. We'll do it together again. So this is what the output's going to look like. So here are the period 1, 2, 3, 4 through 11 actually. So I actually did 11 myself. These were the actual data. And then for 6-period moving average, see 2, 3, 4, 5, 6, you actually don't have 6 periods here, right? Because a 6-period moving average means you have to have 6 periods before you can actually add them and then use it for your next month's forecast. Okay, so that's what this is. And there we have it. So now, how is this calculated? I'll show you in Megastat. Okay. You don't really need to know how it's calculated because you're not going to do it. Megastat will do it, but I'll show you how it's calculated once we go to our spreadsheet. Okay, so there we go. That's what it looks like. Notice, interestingly, for a 6-period moving average, we're going to lose 1, 2, 3, 4, 5, 6 data points. So for example, period 1, I cannot make a forecast because I gotta wait for 6 periods to happen. Okay, so we lose some data up front, but then we can make future forecasts. And so this addresses part B. In part C, compute the math. So here's how you compute the math. Once you have these forecasts, you look at the absolute error. The absolute error is the absolute value of the error of this number, 116 minus 121.8, and this is what I got. And the next one, 118 minus 119.5, take absolute value of that, and the next and the next. And then we total these absolute deviations or absolute errors. So I've got 4 numbers to add. That's the sum of those 4 numbers, 33 and change. And then if you divide this by 1, 2, 3, 4, the number of errors, you get the MAD, mean absolute deviation, which is 8.29. Okay, and that's part C. In part D, what is the forecast demand for period 11? And for period 11, 124 is right here, 124.5. That's the answer. 124.5 is what I have here. That's demand for period 11. And finally, in part E, what is the error associated with the 11th period forecast? Now, if you look at the 11th period forecast here, and there is no actual, right? So you cannot find the error between actual and forecast. So what do? We're going to use math, 8.29. And that would be our forecast. In fact, the future forecast will fluctuate also if we were to continue this on into the future. But at that point, for the 11th, based on what we see here, this is the best answer, 8.29. So we forecast for the 11th period, the demand is going to be 124.5 units, give or take 8.29. Okay, and that's what that is. So that's all we want to do in chapter 14. So it's a brief chapter. It's just a little exposure to time series. Or I'm sorry, chapter 18, not 14. Chapter 18. Okay, now let's actually go to Megastat and see how I got the numbers that I did. Okay, so let me adjust my recording window. So this is where I'm at now. Alright, and what we want to do is we want to actually first do a time series plot, right? The one that I did first. So to do that one, let me shrink this a little bit. Okay, so here's how you do the easiest way. You just highlight these 2 columns, left click and once, left click, hold and drag. So you highlight the graph region. Okay, and then we're going to go to insert, And on the insert, we're going to go to here. You see that? Insert a scatter or bubble chart. Well, we're just going to do a scatter chart. Click on that. And if you just hold the mouse over these charts, you're going to see what the chart's going to look like. There you go. This is what the scatter chart looks like with just the data points. They're not connected, using only markers. This will actually smooth over it. With markers, this will just smooth over it. And this one is markers and lines. This is just lines. Now the smoothing that you see here, by the way, see these smoothings? Let me show you. This is the kind of zigzag chart. This is smoothed. These are not moving averages. Okay, so what Excel does actually uses calculus to do this. So they use spline methods to smooth over these. So these are not moving averages. But let me go ahead and do this. Just click and you pick up this chart. And that's what I had in my note. So that's how you get your time series data. Now if you actually click on this, click on the chart and go to the right. Let me move my recording windows to the right a little more. There. So click on this and here, chart elements. Let me go here, chart elements. See trend line? I can draw a trend line on it. And there we go. That's the trend line. And you can kind of see now. See, there's no trend in this. You see the dotted line here? It's pretty much what I thought it would be. There's no trend. So this is a stationary time series. It's just got some noise here. Cyclicality, or actually no cyclicality. Sorry, I'll take that back. Seasonality. So no trend. It's made up of seasonality and error, random error or irregularities. Okay, that's what that is. And then let's see what else we have here. So that's all. That was just the chart. Now let's actually take a look at Megastat, and I'm gonna go to home, and there you go, home, and let's see, insert, trying to find here file, oops, sorry, okay, I'm trying to find my add-in, hold on. Okay, it's right in here. See that, add-ins? So I go to add-ins, Megastat, then I'm going to go down to time series forecasting. And the only one that we do in this course is moving averages. So just click on moving average. Now your input range, it should be a single column. So click, move that out of the way. And here, I'm just going to highlight the numbers. So this would be our series. That's our time series. And then hit enter. Now notice here number of periods. Well, let's go 3 period. No, actually in the book it said 6. Sorry, let's go 6. And then hit OK. And there you go. That's what I had in my note. And of course you can highlight it. There you go. Now here's something that's important. Put 11 here. And the way your book does things, and most books, and the way Megastat does things are different. Okay, for a six period moving average, 1, 2, 3, 4, 5. Notice this is the 6th data point. In your book, what the authors do is they actually leave the first 6 cells blank. They use the first 6 input numbers, these 6 periods, to come up with the value for the 7th period prediction or forecast. So here's what I need to do. I'm gonna highlight this. I'm going to do a Control X. I'm gonna cut this and paste it one, and paste it, Control V, and paste it one cell below where it used to be. You see that? Now I have 1, 2, 3, 4, 5, 6 blank cells. Megastat doesn't do it, but again, your textbook does this way. Your authors and other time series textbooks do the same thing. Okay? And that's, so you got to be careful. Now, if you wonder how that 121.8 was calculated, let me show you. You don't need to do this. You just want the output, but I'm just going to show you how these two numbers, these two are calculated. Okay? So, first, the 121.8. That's when I'm going to add the first 1, 2, 3, 4, 5, 6 inputs, 6 periods. Add them up, divided by 6. You see that? How is 119.5 calculated? We're going to add the next 6 numbers. 1, 2, 3, 4, 5, 6 numbers, these. And then divided by 6. You see that? So on and so forth. I wonder if I just copy this, you're going to see these numbers. There you go. See how that happened? So if I were to do it by hand, that's how you would do it. Okay. So let me delete these. We don't need them. And okay, so this is these are the forecasts. So for period beginning with for 6 month or 6 period moving average, your first forecast occurs on the 7th period. Okay, so the 7th period forecast is that. 8th period forecast is this, 9th, and so on. The 11th period forecast is this, which is what the book asks for. Now the next column, what I did is I called this absolute error or deviation. And to get the absolute error, I'm going to go down here because up here, see, there's no forecast, so there's no error. So beginning with period 7, I'm going to do this, type equal ABS for absolute value. Absolute value of what? Of this number. So I'm pointing and clicking to that cell, minus this number. Close paren, and enter. And there we have it. See that? So this is the error again. ABS means absolute value. Now if you go to the lower right, you see this plus sign. Left click once, drag it, and it will copy it to the other cells. Otherwise you have to just retype the formula. Now notice, don't do it for this one because there is no observed value. There is no actual, so there is no error in that one. So let's find the total. So I'm going to do the sum of these errors. The total error is going to be equal sum, open paren, and then just left click once, hold and drag, close parentheses, and enter. That's the total absolute error. And your MAD, mean absolute deviation, is equal, point to that cell, this number, divided by, there are 4 deviations, 4 errors, divided by 4. And that's how I got the 8.29. You see that? So hopefully you're able to follow this. So it's important again that you move this one level lower. Now just to show you, let me try to do this. So we're done. we're done with this one. That's how you do your forecast with 6 period moving average. But I want to do a 3 moving average. Okay, a 3 period moving average for the same data, and to show you how it's done. So I'm gonna go add-ins, make a stat, and again you can just watch this. You don't have to do this unless you like to. I'm gonna go moving average, same data, do it with 3, and hit OK, and it's down here now, right? I'm gonna get these moving averages, Control C, copy these and move them up here, side by side. So now I have a 6 period moving average and a 3 period moving average. Notice for 3 period moving average, Megastat shows 2 empty cells, and it uses the sum of the first 3 divided by 3 to show the 3rd period forecast. Again, I'm going to highlight these, Control X, move it 1 cell lower, Control V. So I shifted everything down by one unit. So just like in your book, 1, 2, 3. The first 3 are blank. Okay. And these are the forecasts. Now, let's compare the 7 period forecasts. The 6 period moving average finds it to be 121.8 versus 119.3. The 11 period forecast based on 6 period moving average is 124.5, whereas if you go 3 period moving average is 128. So notice how things are really different, aren't they? Just depends on what we want to do, right? And let's do the math here. So I'm just gonna find the total deviations. That would be, oh, actually, sorry. I need to do my absolute errors. And beginning with the 4th period, I have an error. So that's going to be the absolute value of the actual minus the forecast. Close paren, hit enter. And then if I go to the lower right corner of that cell, grab the plus sign and drag it, and I get those deviations. Just like we totaled them here, I'm going to total them here. So I'm going to go equal sum, left click once and drag, close paren, and there you go. That's the total, which is much larger than that, but then we're going to divide by bigger denominator, right? How many deviations? 1, 2, 3, 4, 5, 6, 7, and 8. So I'm going to go this number divided by 8. And wow, look at that. Our forecast, let me see, actually, sorry, I don't need to do it for the 11th period. See, right here, the 11th period, there is no actual number, so I need to delete the error associated with 11th period. And we're going to divide by 7 now, right? Not 8. Because there's 1, 2, 3, 4, 5, 6, 7 errors. So I'm going to divide that by 7. Just looked too high. There you go. That's better. I'm good with that. I'm going to go home and highlight this one. Okay. So there you go. Just want to show you the difference in the forecast errors. You see that? So let's say for the 11th period, the forecast was 124.5. Oh, and this one I erased it. Let's see, I can reclaim that one if I just let me bring that number back. Okay, I got it back. It was 128.3. So the 11th period forecast for demand using 6 period moving average is 124.5. Using 3 period moving average is 128.3. Our first forecast is off by as much as 8 units. So it's anywhere anywhere from, let's say, 116 to 132. This one, 128 minus 13, anywhere from 113 or 116, no, 13, 115 to all the way up to 140. Okay, so that's how the moving averages work. All right, so we're done with this lecture. Let me go back to note, and in my note everything looks fine. Let me bring it lower, and okay, we're good. So again, to wrap up, we just talked about components of time series, and in our discussion we only talked about simple moving averages, and that should do it. And hopefully you enjoyed this topic. Very useful stuff, right? Good luck predicting future value of your favorite stocks. All right, we're done with this lecture.